Running TensorFlow jobs. A job refers to a program running on a cluster's compute nodes. These jobs can be run in two different ways: interactive or batch. Interactive jobs. The interactive session will only work on a single node. In order to use TensorFlow, an interactive session with Python will be used. To start an interactive session on a compute node and launch Python, the following command can be used. Here we see that the srun command is used to allocate one node with one process for 1 hour, utilizing one GPU, and bash selected as the terminal environment. After which, the module necessary to use TensorFlow is loaded. Finally, an interactive Python session is started by typing Python into the command line interface. Let's now take a look at a demonstration of the process. Here is an example usage of a Python interactive shell session. In this example, the first 2 lines of code are commands that help suppress the printing of information from the GPU device and the TensorFlow library. And the NumPy library under the alias np. The TensorFlow library under the alias tf. We first import from Keras a densely connected and end layer. Then initialize 2 variables that take as input a list of tensors that all have the same shape. Next, you can use multiply to multiply your 2 variables. That returns a single tensor that also has the same shape. Store the result in the multiply variable. And lastly, print out the result. Now suppose instead of using an interactive Python terminal, we want to execute a Python script with lines of Keras code directly. This can be done within an interactive session, as shown below. Here we have a file called examplekeras.py, which contains the 7 lines of Python code previously used in the interactive terminal session shown below. Like the interactive Python session, we first need to ensure that the Python module is loaded. Then we pass the examplekeras.py script to the Python interpreter using redirection. After the script is executed, you can open this file and see the result. Now let's look at an alternate way to execute our example Keras script file. Here we will use a Slurm batch script to both allocate the necessary resources and execute the example script. This batch script called examplekeras_job.sh is shown below. There are 3 main components of a Slurm batch script. The first line specifies what terminal environment to load. The second section is the series of allocation specification, all prepended by the special word sbatch. Looking over the allocation specifications, we can see that the job is being given the name my_Keras_job. The execution output summary is being specified as my_Keras_job.o%j. A total of 1 hour is being requested. A single node with a single core and a single GPU are being requested. The last section is what the script will actually execute, which involves loading the necessary Python module and then execution of the script using redirection for the input and output. Once the Slurm batch script is configured, The script can be submitted to the research negotiator as follows: s-batch example keras _job.sh. Note the example keras _job.sh script assumes the input keras script is contained in the same directory that it is executed from. As the job runs, its progress can be monitored via the sq command. And once it completes, the specified output file compute.out will be populated within the submission directory. For technical support or to request a consultation, please visit us at support.hpedsi.uh.edu. For general inquiries, please write us at contact@hpedsi.uh.edu.